Hello, fifth graders. We're going to begin this video with a kind of question that I asked very early in fifth grade. Pretty much as soon as we define fractions as points on the number line, identifying, realizing, and getting into our long-term memories that the denominator or bottom number of a fraction is telling us how many equally sized pieces the unit has been divided into. The unit is the distance between 0 and 1, and then that is copied, that distance is copied between 1 and 2, 2 and 3, and so on. So the denominator tells us how many equally sized pieces 0 to 1 has been divided into. This is the kind of question that you need to be able to easily answer very soon. How many fifths equal 4? Well, like all of math, that being able to answer that question depends on a more basic concept, the one that I pretty much just said. We could go back to this more basic question, how many fifths equal 1? Well, it's really right there in the definition of fraction. When you see that denominator of 5, you know that the unit, the distance between 0 and 1, has been divided into 5 equally sized pieces. So by definition, 5 fifths is 1. So let me replace this question mark with 5, and then direct your attention to, I made a fifth number line between 0 and 1. I spaced these 4 points in between. Remember, to create a fifth number line, you have 4 equally spaced points between the 0 and the 1, which creates 5 equally sized pieces. And I sometimes indicate that with a little jump with the marker. 1, 2, 3, 4, 5. So when you get to that whole number 1, the point that is the whole number 1, you are at the fifth. Now, I have intentionally not indicated the fifths the rest of the way. I did that on previous videos. I think we had a thirds number line that we looked at extensively last time. But I also suggested last time that you progress to a place where you are thinking abstractly. Early on, to picture the number line in your mind, or even to sketch one out on a piece of paper as needed, is of course something that I would encourage. But I also encourage the movement toward abstraction. Do you think maybe you can answer this question? Realizing that 5 fifths is the whole number 1, how many fifths would we need altogether to get to the whole number 4? Did you think it might be 20? That's the answer. That's how many fifths it takes. That's how many fifths exactly equal the whole number 4. Got a marker that's not cooperating here. 20. I'm going to have to switch to another color here, folks. Sorry about that. 20 fifths equals 4. Now, I previously sort of jumped ahead, did something that maybe isn't supposed to come immediately with the study of fractions, but you can think of a fraction as a division, reading it from top to bottom. 20 divided by 5 is 4. That's fine. That's definitely something that's going to help you with the abstraction going forward. But at this point, I want you to truly believe that it's true and not just because 20 divided by 5 is 4. Let's look at the number line. I'm not going to physically construct the fifths, but let's imagine them, all right? If I were to physically construct the fifths between 1 and 2, it would look just like between 0 and 1. So 1, 2, 3, 4, 5 more fifths would bring us to 2. But if we go 5 fifths past 1, we're then at 10 fifths. There are 5 fifths between 0 and 1. There are 5 fifths between 1 and 2. So now, getting to 2, we're at 10 fifths. And then, of course, 3, the whole number 3 would be 15 fifths. And then over here, the 4 would be 20 fifths. please imagine all of those fifths being there. And it's quite clear that the 20th fifth to the right of 0 is right on top of the whole number 4. This question is going to be easier for those of you that have learned the 12 times tables. 60 fifths. You can read it as 60 divided by 5. Think about what it might be. 12. 60 divided by 5 is 12. 60 fifths is indeed 12. Let's do something, an analysis, a way of looking at this that I did previously on a previous video. Let's imagine a whole series of 5 fifths being added together. Dot, dot, dot. And then question mark. How many of those 5 fifths would we need to add together to get to 60 fifths? Right? 60 fifths over here. How many 5s are in 60? Counting by 5s. How many 5s do you have to count to get to 60? Well, 12 times 5 is 60. So this would be 12 5 fifths being added together to get to 60 fifths. And each of these 5 fifths is 1. So we have 12 ones being added together, which is, of course, 12. All right? Now, in terms of imagining the number line, this number line only goes up to 4, but we could certainly imagine continuing. Every time we go up by 1 whole, every time we go up by the unit, we go up by another 5 fifths. If we continued here, the whole number 5 would be 25 fifths, and then 6 would be 30 fifths, and so on. We would be at the whole number 12 when we got to 60 fifths. Maybe we could look at it this way. 3 times 4 equals 12. How about 3 times 20 fifths? Now, this is something we're definitely not at yet, but a few weeks or a few months down the road, you'll be easily multiplying fractions, multiplying a whole number by a fraction. But let's just think of this 3 times 20 fifths. Let's just think of it the way we learned to think of multiplication in 3rd grade. 3 times 20 fifths means 20 fifths plus 20 fifths plus 20 fifths. Add 3 20 fifths together. And that, of course, would give us 60 fifths. So it's just like taking what we see on the number line now up to 4, which is 20 fifths, and then tripling it down further on the number line until we get to the whole number 12, which is 60 fifths. If you have not convinced yourself yet that 60 fifths is 12, please go back. Pause, rewind, go back, rewind. That's an old word when video things used to be on tape, which we would have to literally rewind. I think we still call it rewind, but doesn't really apply anymore. Put your cursor, go back a couple of minutes, and convince yourself that 60 fifths is 12. Once you do that, being asked the question, what is 63 fifths? Is a very simple matter. And by the way, if you want to know what it is we're doing right now in terms of what it would be called in the textbook, or if you Googled and you went onto something like Khan Academy that was going to explain it, what we're doing is we're converting or changing an improper fraction to a mixed number. Can you figure out what the mixed number is that is the same as 63 fifths? Based on your prior knowledge, and remember, a mixed number is a whole number plus a fraction that's less than 1. A normal mixed number, for example, 3 and 9/4. That's a number, and in the future we'll need to be able to convert this into a normal mixed number. But this is not a normal mixed number. For a normal mixed number, we want that fraction part to be less than 1. Because 3 and 9/4, even though it is a particular number, it's a little bit misleading, because you might look at it quickly and think, well, it's 3 and something, so it's less than 4. No, in fact, this is something some of you might be able to appreciate right now. In the future, we're going to have to convert something like this the following way. Realize that 9/4 is 2 and 1/4. So for this weird mixed number, 3 and 9/4, it's actually the same as 5 and 1/4. Now that's a normal mixed number. And for the point on the number line that is 5 and 1/4, it's much easier to think of it this way than this way. Okay, so just wanted to throw out that little understanding about mixed number, the normal mixed number. We want that fraction to be less than 1. What about 63/5? If you know what 60/5 is, then it's a very easy matter to come up with the mixed number that is equal to 63/5. Just break down the 63/5 to 60/5 plus 3/5. We already know that 60/5 is 12. And then here's that easiest of all questions in middle school math. What is 12 plus 3/5? Well, it's the mixed number, 12 and 3/5. So just to make a little quick sketch of the number line, the one up there only goes to 4. But let's say that this is 12, and this is 13 is right here. 63/5 is between 12 and 13, between the whole numbers 12 and 13. This whole number 12 is 60/5, as we've discussed. How many fifths would 13 be? The whole number 13 is how many fifths? Well, you need 5 more fifths than 60/5. So this would be 65/5, right? And now 12 and 3/5, divide the number line into 5 equally sized pieces. Each of these is supposed to be a fifth. 1, 2, 3, 4, 5. And then go to the third one, right there. Okay, that's 3/5 past 12, so it's 63/5, but it's also 12 and 3/5. 63/5. The 63rd fifth from 0 is 3/5 past 12, so it's 12 and 3/5. Now, I have not to this point made the following connection. I have said that a fraction can be thought of as a division from reading it from top to bottom. 63/5 is 63 divided by 5. But what I haven't talked about is the long division algorithm. Long division that we do on paper. And how does it relate to this kind of skill of converting an improper fraction like 63/5 to a mixed number? Well, writing the divisions 63 divided by 5 in another way, of course, there are 3 ways to write 63 divided by 5. 63 divided by 5, we learned that symbol in 3rd grade. And then we also learned that if we have to do that division algorithm, we put this 63 inside, 63 divided by 5 when we go ahead. And now we're seeing a 3rd way, and the way that going forward, more and more, we're going to represent divisions as a fraction like this. So let's take this one, the long division algorithm, like that. And of course, now you might be able to jump right to that and realize that 12 times 5 is 60. But if you take it a digit at a time, of course, You'll do 1 times 5 here, put the 5, subtracting get 1, bring down the 3. How many 5s in 13? 2. 2 times 5 is 10. Okay. And in 3rd and 4th grade, when we do 63 divided by 5, we say this, that the answer is 12 remainder 3. Now what that tells us is there is no whole number that we can multiply 5 by to get 63. What we need to do is, if we're strictly thinking about whole numbers, 12 times 5 plus 3. This is 60 plus 3 gives us the 63, which is inside. That's just the basic long division algorithm, getting a quotient and a remainder. But we're going to, sometimes, if you need to, use long division and quotient and remainder, but we're going to make a slight adjustment to that. Well, the first thing I want to point out is, let's go back and assume that you know that 12 times 5 is 60 and sort of take a shortcut with the long division algorithm, because you don't see the number 60 here. It's sort of hidden in the digit by digit approach of the long division algorithm. Let's do this. 63 divided by 5, put a 12. 12 times 5 is 60. Now there's the same remainder. So in 3rd grade or 4th grade, if you could take that shortcut with the algorithm and just immediately write the 12 and remainder 3. Okay, but what I need to point out to you here is this 60 right there, that 60 is the same as the 60 up there. You see, to me, this is the best way to think about 63 fifths resulting in 12 and 3 fifths. To break down the 63 fifths as 60 fifths plus 3 fifths, making sure that this fraction over here is less than 1. And then, what is this as a whole number? It's 12. 60 divided by 5. And there it is in the long division algorithm, if you take that shortcut. Sometimes the long division algorithm sort of hides things because we do it digit by digit. But there it is. Now what about remainder 3? Well, this will work, ladies and gentlemen. We can take this remainder and bring it up here and put it on the top of a fraction. And then the 5 that we're dividing by goes there. There's 12 and 3 fifths, which is the mixed number, which is 63 fifths. Remember before, when I was talking about division with remainder, when a 3rd grader or 4th grader is doing 63 divided by 5 and gets 12 remainder 3, as I said before, that's 12 times 5 plus 3 equaling 63. And to the 3rd and 4th grader, the presence of that remainder is because there's no whole number that you can multiply 5 by to get the 63 inside. Notice I said there's no whole number that you can multiply 5 by to get 63. But there is a number that you can multiply 5 by to get 63. Do you want to think about what that number is? 12 and 3 fifths. And if this seems a little mysterious at this point, don't worry. I sometimes like in my instruction to give previews of things to come. You're going to appreciate those previews at different levels. Some of you more than others. Some of you will remember down the road, or you'll look back at this video maybe if you want to reminisce, and you say, oh, okay, in the future, the near future, we're going to be able to take 12 and 3 fifths and multiply it by 5 to get 63. Don't be intimidated. As I said, I like to give little previews of things. So the long division algorithm, if you need it, is there. Notice this, what we do in the end, once we get the remainder. That becomes the numerator of the fraction part of the mixed number. And the divisor here, the 5, becomes the denominator of the fraction part of the mixed number. Oh, this one's fun. 76/17. In order to understand 76 17ths, go ahead and construct a 17th number line. Between 0 and 1, divide into 17 equally sized pieces. Would you rather not do that? Can you abstract it? Can you imagine it in your mind? So the distance between 0 and 1 has been divided into 17 equally sized pieces. We take those little jumps, beginning at 0 and jumping 1. It's 1 17th, 2 17ths, 3 17ths. How many 17ths would we have to jump to land right on top of 1? By now you should know that. 17 17ths is 1. Even if we don't want to construct it, we understand abstractly how fractions work, and we're very confident in that. Okay? Well, do you want to try to figure out how many 17ths 2 is? And now we're back to that kind of question we saw before. If you're confident with 17 17ths being 1, how many 17ths equal 2? Well, don't you have to go 17 more 17ths to go from 1 to 2? Of course. Now, we don't learn the 17 times table when we're young. I didn't. I'm doing this on purpose. It's moderately challenging, but I want you to realize even when the numbers get hard, that doesn't change the underlying math. Did you think about it? 34 17ths equals 2. 34 divided by 17 is 2. Looking at it backwards, as we do, 2 times 17 is the 34. Whenever you have this kind of situation, a fraction, number over here, the fraction is a division. How do we check a division? By multiplying. 2 times 17 is 34. We'll see more of that kind of thing later. Well, 7, let's go back all the way to basics. 17 17ths plus 17 17ths. This is 1. This is 1. 1 plus 1 is 2. 1 plus 1 is 2. And if you were to add 17 17ths and 17 17ths, the denominator stays the same. 17 plus 17, adding the two numerators, is 34, which of course is 2 times 17. We'll go all the way one by one on the number line. If you can be convinced now that 34 17ths is 2, we now have to ask how many 17ths is 3. And you don't have to reinvent the wheel. You don't have to think what is 3 times 17. You could. That's not that hard. You should be able to do 3 times 17 mentally using the distributive property. 3 times 10 is 30. 3 times 7 is 21, and add them together, right? Or you could just go back here. 2 plus 1 is 3. So if we add 17 17ths here, another 1, right? Plus 1. Over here, plus 17 17ths, we get to 3. And 34 plus 17 is 51, which is 3 times 17. So the whole number 3 is 51 17ths. And we only have to do this one more time. How many 17ths is 4? If I had, you had encountered this right here all by itself before this video, or certainly before the previous video, defining fraction, that would have been probably challenging for almost all of you, right? But now we see it's a very simple matter. We just add We can add 1 to 3 to get 4. So add 1 to the 51/17, but realize that 17/17 is 1. So you add 17 to the 51 to get 68. The answer here, that numerator is 68. You can think of getting to this 68 by adding 17/17 to the 51/17. We already saw that that's 3, and 17/17 is 1. 3 plus 1 is 4, and 51/17 plus 17/17 is 68/17. What is 68 divided by 17, ladies and gentlemen? It's 4. Or, checking that, why is 68 divided by 17 4? Why? Because 4 times 17 is 68. And again, the distributive property, you can do 4 times 17 mentally. This is what the algorithm tells us to do. Put down the 8, carry the 2, 4 plus 2 is 6, like that. But you can think of it this way. 4 times 7 is 28, and 4 times 10, that 1 is not really 1, it's really 10. 4 times 10 is 40. 28 plus 40 is 68, and you can do that mentally. All right? The original question was 76/17. And by the way, I guess we'll go one more time, because just to make sure everybody sees that 76/17 is less than 5. Because if we had another 17 here, we get 85. 85/17 is 5. 5 times 17 is 85. But we don't have 85/17, we only have 76. So, up here, what we do is we think of the 76/17. Come back to this. Think of it as 68/17 plus how many 17ths? Now I want to make, while you're thinking about that, I want to make this point. You know, you might have been inclined, your natural inclination might have been, if you want to break down 76/17, maybe think of it as 70/17 plus 6/17. Now that's certainly true. 70/17 plus 6/17 is 76/17. It's true, but it's not helpful. Because 70/17 is not a whole number, but 68/17 is. Right? So back to this question. It's pretty easy. 76/17 is 68/17 plus how many more? And isn't it 8? 8/17, right? 68 plus 8 is 76. So what mixed number is equal to 76/17? Well, this is 4 plus 8/17, that easy question again, 4 and 8/17. When you're at 68/17, you're right on top of the whole number 4. And then if you go 8 more 17ths, you will be at 76/17. This and this are the same point on the number line. That is the most important concept in all of fractions and even math, all of math, you know, that these numbers that we are dealing with in K through 12, or certainly K through 8 school, they're points on the number line. And we've defined what fractions are. Fractions are all about dividing the unit into a certain number of equally sized pieces. One last thing to do here. I'll erase down here to bring back that division algorithm, the long division algorithm. This is a division, 76 divided by 17. We go like that. Now, the first thing you have to do here is ask yourself, how many times what can I multiply 17 by to get close to 76 without going over? And the part I erased down here, we were actually doing that, right? If you approach this fresh without me having done anything else, you would have arrived at the conclusion that we need to multiply 17 by 4 to get close to 76 without going over. It's like the Price is Right rule. You can't go over, right? and we might have had to try over here. We might have to try 2 times 17, 3 times 17. Maybe we try 5 times 17 and realize it's too big. Well, of course, as we saw before, that's 68. 4 times 17 is 68. And notice, ladies and gentlemen, I put that 4 in the ones place. It doesn't belong here in the tens place because 10 times 17 is more than 76, right? So that 4 belongs in the ones place. This is a subtraction, of course. 76 minus 68 is 8. We essentially had to do that back here when I asked you, what do you add to 68 to get 76? That's the 76 minus 68 that you see here. So the long division algorithm sort of reflects some of the thinking that we did back there. And now the 3rd and 4th grader, well, probably not 3rd grade because, I don't think 3rd graders get in much to 2-digit divisors. It's even kind of challenging for 4th grade. We will do that a little bit this year, review it, and get you a little bit comfortable with having a 2-digit divisor out here. But the thing about that is it often requires experimentation. You got to off to the side. You got to do this off to the side. You may not be able to do it mentally. So it just takes a little bit more perseverance. But of course, as we saw before, what we can do is take the remainder of 8, put it up there in the numerator, and then the 17 becomes the denominator of the mixed number. Rather than say 76 divided by 17 is 4 remainder 8, we can come up with the mixed number by that little process. The 8 on the top, the 17 on the bottom. It will always work that way. And if you're wondering, why do we work that way? Well, 2 things. Later on, we will see that this mixed number times 17 does equal 76. Don't be intimidated by that. We'll get there, and it'll be easy once we do. But I think now what's more important is seeing the connections, seeing the fact that this 68 here in the long division algorithm is the exact same 68 up there when we broke the 76/17ths down the way we did. It's the same 68. And of course, this 8 and this 17 are in the fraction part of the mixed number over there. So we've gone over 30 minutes. The beauty of YouTube instruction is it's there forever. You can go back and everyone's different. Each of you needs to decide, have I mastered this? Do I fully understand? Maybe I have to go back. If if I give you some quiz problems and you don't get all of them right, maybe you can go back here and refresh your memory about it. It's maybe a lot early in 5th grade to deal with 17ths, but I made that conscious decision. I always want to challenge you, get you to the next level, and just do the best you can to understand as much as you can. Circle back to work on the understandings of concepts and skills that maybe you don't get right away, but it'll come. Math is a wonderful journey, and enjoy it. Bye-bye for now, 5th graders.